Now we'll study about the principal properties of logarithm. Principal properties of the logarithm. Let's study about the first property, log a m into n. Log a m into n is equal to log a m plus log a second. Log a m upon n is equal to log a m minus log a n. Now before moving ahead, let me explain you with some certain example here. Log 2 m into n, say 4 into 8, right? This should be equal to log 4 to the base 2 plus log 8 to the base 2. Let's check. This quantity 4 into 8 is 32, right? Now 2 raised to power something which gives you 32 is 5. 2 raised to power something which gives the value 32 is x is 5. Therefore the value here is 5. The value here is 2 raised to power something equal to 4 is 2, and 2 raised to power something equal to 2 raised to power something which is gives the value 8 is what? 2 raised to power x equal to 8. That means x is 2 plus 3. Now obviously 2 plus 3 is equal to 5. Therefore we verified this theorem or this identity as true, and similarly it can be taken for the division also. So whenever you get the two quantities, you can separate them out in form of addition. Now important thing over here is m into n. This is the product and this is the division, and split it out into the addition and subtraction. This is a very important here. It means multiplication and division is split it out into the addition and subtraction, right? Now next is third one, which is we call as base change theorem or base change. Log a to the base m to the base a. Suppose while doing the problem we have arrived that we are not able to solve the problem, we need to change this base, because in addition and subtraction we least saw the last time in the multiplication and division we saw that the base is common here. So in this addition subtraction the base is a here, the base is a here, base is a here, because whenever we deal the problems base should be same. Suppose there is a problem, base of certain logarithm is not equal. What we have to do, we have to change the base into the required base. Now this is the base change here. Now in the base change what we do is log m, here is a, we put the base whichever we need. Suppose we require the base b, we put here this, then again we divide this equation with the number a to the base b. Now this is the value, these two values are equal. Here we change the base to the b. In this way we can change, or let me teach you the learning way, how you learn this. What you have to do, m to the base a, you put the line here, put the base b here, and put the base b here. Now this is log b to the base m, log b to the base, right? Third. Now the fourth thing is log a m into log m a is 1. Log m to the base a and log a to the base m, if you multiply these two quantities we get the value as 1. Or we can say that log a to the base m is equal to log m to the base a 1 upon. How can you say that? Using this third formula. Imagine how you use this to get this value. Try to change the values from a to m, you'll get this result. The fifth important property here is a raised to power log a to the base n is, if sometimes we get the same thing here, the base is a and the exponent again a is, we get the value n. So this is the required results. And sixth important thing is log m to the power n to the base a is equal to n log m to the base a. That means if you have a quantity that has some power, that comes into the multiplications. Seventh important thing is log a raised to power q and n raised to power p is equal to p by q log n to the base a. This is again very important. So these are the basic fundas of the logarithm. There is one more important which is you require to remember. This is a very good formula over here. P raised to power log a to the q is equal to p raised to power logarithm to the base a q is equal to q logarithm to the base a. I'm repeating the 8 point again. P raised to power log a q is equal to q log a p. It means you have to remember this p and q can be interchanged according to the problem. So these are the very important rules. Let's come to some problems over here. Log a 3 to the base log a to the base 3 is equal to 4. Now the value of a here is a equal to 3 raised to power 4, that is 81. Right? Let's do a few more problem here. Find the value of log 9 upon 8 minus log 27 upon 32 plus log 3 upon 4. Now here we use the first and second law of the property. Imagine the first and second law. What was that? Of addition and subtraction. Means I can say the base is not written here. Means by default the base is 10. The important point over here is base is not written. Therefore, that's not written. Therefore, by default the base is 10. Right? We assume base is 10. Then this are in subtraction and multiplication. Whatever the quantity in subtraction we divide it, that is 27 and 32 become 32 by 27, and those on the addition will get multiplied. That is using the log mn features, mn equal to log m plus log n. We have done this. 8 4s are 32, 4 and 4 are cancelled out, 3 9s are 27 and 27 cancelled out. We get the value log 10. Log 1 to the any base, the value here is right. Next one, 2 log 4 x is equal to 1 plus log 4 x minus 1. Find x. Now 2 log 4 x is equal to this 1 plus log 4 x minus 1. Now if I transform this quantity here, 2 log 4 x minus log 4 x minus 1 equal to 1. Now this is has the base 4, this has the base 4. Both have the same base and subtraction. Yes, we can do some applications here. Now this is 2 log. The 2 log x can we can say that log x to the base 4. 2 is moved here, that is x square. We know that x is to power n is n log x. Right? This was the property again. Now this is the x square minus log 4 x minus 1. Yes. Now here is subtraction. Here is subtraction sign, therefore we divide these quantities, that is x square upon x minus 1 equal to 1. Now this is x square upon x minus 1 equal to 1. Now x square upon x minus 1 equal to 4 raised to power 1. That is, now we can solve this. Now this becomes the quadratic equation, right? Now this is x square minus 4x plus 4 equal to 0. That is x minus 2 whole square equal to 0, or x is equal to 2. Now whenever you get the result in solving the equation, you have to verify whether it is satisfying the equation or not, whether the given logarithm is into the negative stage or not, whether the value of base is 1 or not. Now if you put the x2, the base will not change. X2, there is no problem here. X2 means 1, there is again no problem here. Therefore x is equal to 2 is the answer for this problem. In logarithm, you should remember that you have to check the whatever the answer comes out, you need to check with the original problem. 3 raised to power 2 minus log. Let's solve this problem. 3 raised to power 2 minus log 3 upon. I can say 3 raised to power 2 into 3 raised to power minus log. Yes, we can separate it out. Yes, we have separated it out. Now 3 raised to power 2 is 9 into 3 raised to power minus log 3 5. Now this 3 and 3 are the same. Now minus sign. Now if we want to remove the minus sign, I can say this is 5 raised to power minus to the base 3. Now minus sign is reduced. There is nothing here. Now this 3 and 3 are the same. Now we can say 9 into 5 raised to power or 9 upon. Next problem, log 25 125 minus log 8. Now this 25 125. I can say log 25 raised to power something which is get 125. Now it's difficult to analyze what something 25 raised to power to get the 125. No need to worry. We say this is 5 raised to square, this is 5 cube, right? Minus log 8 is 2 cube and 2 is 2 square. Similarly here, because it's very difficult to analyze what 8 raised to power something to get the 4. Now this is 3. We remembered the formula over here. This is 3. Can take out the 3 here. 2 again 3 by 2 log 5 to the base 5 minus 2 by 3 log 2 to the base 2. Now 5 to the base 5 is 1, that is 3 by 2 left with. Here we left with 2 by 3 because 2 to the base 2 is 1. 3 by 2 minus 2 by 3 is as simple as that. You get the answer over here. The next thing we'll discuss in the next video about the fundamental logarithm identity and few fundamental logarithm identity and the graph of the logarithm. So how the logarithm vary with the x-axis and y-axis. Thank you for this video. Thank you.